We're given 2 power x plus 2 power y equal to 2. Now here y is f of x. Okay. So firstly we'll see this. So 2 power x equal to 2 power 2 minus 2 power y. See, if you know the graph of exponential function, it is something like this. It's strictly non-zero. So obviously this is 2 minus a strictly non-zero term. So 2 power x equal to 2 minus something non-zero. Correct? So 2 power x is less than 2. So x is okay. So y is okay. This is 2. Okay, 2 minus 2 power 1. So this is strictly less than 2, right? I mean less than 1. So x is less than 0. Less than 2 minus 2 power y. This is greater than 1. Y is positive. So 2 minus 1. This is 1. But at x equal to 0, 2 power x equal to 1. If 2 power x is less than 1, that means what? X must be less than 0 because 2 power x is an increasing function. That's all you need. You can never equal to infinity. You can never have equal to 0 also. So the answer is D. This clear, everybody? Hello? Okay. This is positive when you are doing this. See, 2 power y is greater than 1, right? For y positive. That's what I'm saying. So if it's greater than 1 means what? Minus 2 power y is less than minus 1. When you add 2, you get what? 2 minus 2 power y is less than 2 minus 1, which is equal to 1. So that is why you get 2 power x is less than 1. From that, you infer that x is less than 0 because 2 power x is less than 1 implies x is less than 0. Next, so but there is no restriction other than that. So x greater than minus infinity and x is strictly less than 0. X cannot be equal to 0 also. Next question. F of x equal to sine of pi by 6 into sine of pi by 2 into sine x for all x belongs to R, and g of x equal to pi by 2 sine x for all x belongs to R. Let f of g of x not f of g of x. I mean that's a denotation composition. This is denotation for composition. Okay, composition denotation. G of f of x is again composition, and which of the following is true. So first you should find what is the range of f of g, and limit x tends to 0 f of x by g of x. Okay. First we'll see how do you solve this problem. Okay. So minus 1 less than or equal to sine x is less than or equal to 1. So minus pi by 2 less than or equal to pi by 2 sine x is less than or equal to pi by 2. So we take sine is an increasing function from minus pi by 2 to pi by 2, correct? Or else not. This is sine, this is this thing. Okay. So minus pi by 2 here and plus pi by 2. So sine is an increasing function, so the order will not change. Minus 1 less than or equal to sine of pi by 2 sine x less than or equal to 1. Then again multiply by pi by 6 on both sides. So you get what? Minus pi by 6 less than or equal to pi by 6 into sine of pi by 2 sine x less than or equal to pi by 6. Now again take sine on both sides because sine is again, see, pi minus pi by 6 is again a sub-interval of this. It's still strictly increasing. So when you take sine on both sides, you get what? Minus half less than or equal to sine of this entire thing is f of x. F of x less than or equal to half. So option A is correct. Okay. So now we want to find range of f of g. So we'll write f of g sine of pi by 6 of sine of pi by 2 of sine x, sine of pi by 6 of sine of pi by 2 x. Correct, right? That's it. Pi by 2 sine x. Okay, okay. So f of x equal to sine of pi by 6 of sine of pi by 2 sine x, sine of pi by 2 sine x. This is what is f of x. Now g of x is what? Pi by 2 sine x. Now you should find range of f of g. F of g of x. That means here you should put pi by 2 sine x. So which is same as sine of pi by 6 of sine of pi by 2 of sine of pi by 2 sine x. So there's a trick in solving this problem. This lies between what? Minus pi by 2 to pi by 2. We'll do it fastly. This lies between minus pi by 2 to pi by 2. Correct. Sine of this thing again lies between minus 1 to 1. Again, pi by 2 lies between what? Minus pi by 2 less than that value less than pi by 2. Again, sine minus 1 less than that value less than 1. Again, if you take pi by 6, minus pi by 6 less than this entire thing less than pi by 6. Now, if you take sine, you get what? Minus 1 by 2 less than this entire thing less than 1 by 2. So even for f of g of x, the range doesn't change. The range is the same even for f of g of x. Correct? Minus 1 by 2 less than 1 by 2. So this comes. Next, limit x tends to 0, f of x by g of x equal to pi by 6. Let's try to solve this problem. Okay, there's another problem coming. We'll do it here itself. It doesn't take much time. So 1 minute. Okay. So what is f of x by g of x? So this you can split, right? This is limit x tends to 0, f of x by limit x tends to 0, g of x. Correct. We'll compute them separately and take the ratio. What is limit x tends to f of x sin x? You can divide by x and multiply by x. But this is okay. So that is same as limit x tends to 0 sine of pi by 6 of sine pi by 2x. Why? Because when you multiply and divide by x, this limit of this is 1. So you will be left with this. Again, what do you do here? Divide by pi by 2x and multiply by pi by 2x. This is what? So this as x tends to 0, pi by 2 x also tends to 0. So this also will become 1. So you are left with what? Limit x tends to 0 sine of pi by 12x. Okay. Now again multiply by pi by 12x and divide by pi by 12. So the numerator is pi by 12x. Similarly, the denominator will be what? Pi by 2x. Pi cancel, x cancel, it will be what? Sorry, pi square. Where did we go? Yeah, here it comes pi square. Pi cancel, x cancel, you get what? Pi by 6. Okay. So option A, B, C are correct. So you see, the option D deals with g of f. So there is an x such that g of f of x is equal to 1. We'll see if that is true. Oh, g of f of x. Okay. So g of f of x means what? Pi by 2 into sine of something, correct? Why should there be such a thing? If you want to bound it, it will be from okay, it's okay, fine. I'm just going to write here somewhere because there's a new screen now. Okay, so you see, if at all you want g of f of x to be equal to 1, that means what? G of f of x equal to 1 means this sine of this entire thing must be equal to pi by 2, correct? Okay, but sine is always bounded by 1, no? What is pi by 2? Pi by 2 is approximately 3.14 by 2, which is greater than 1 because 3.14 is greater than 1. So can sine of something be greater than 1? It can never happen. So this is wrong. Simple logic. G of f of x becomes pi by 2 into sine of something is equal to 1. So sine of something must be equal to 2 by pi. It can never happen, right? Because it's greater than 1. So you can just decipher it based on just looking at the bound of sine x. So, that is the reason functions is a very complicated subject. It's not unlike the trigonometry or where you have some set of defined techniques. You do not know which technique you have to use, but we are trying to cover the maximum number of techniques here. Anyway, so next it's the third question, in which fn of x equal to summation tan inverse 1 by 1 plus x plus j into x plus j minus 1. See, whenever you're given tan inverse and the difference is 1, the immediate thing you should do is you should write the numerator in terms of denominator. That is, write the numerator as x plus j minus x plus j minus 1. This is also same as 1, but why am I writing like this? So that this can be expanded as tan inverse of x plus j minus tan inverse of x plus j minus 1, which is a telescopic series. Always look for telescopic series in your problem. Okay. This is same as what? When you expand it from equal to 1 to n, what do you get? This one. I'll do it here. Tan inverse of, that is tan inverse of x plus 1 minus tan inverse of x plus tan inverse of x plus 2 minus tan inverse of x plus 1. So on so tan inverse of x plus n minus tan inverse of x plus n minus 1. Cancel this, and this also will get cancelled by something here. So fn of x equal to tan inverse of x plus n minus tan inverse of x. Now what is this? Tan inverse of n by 1 plus x into x plus n. So, see all the options tan of fn of x. So we'll also take tan of fn of x. That says what? Tan of fn of x equal to n by 1 plus x into x plus n. Okay. Okay. Now first option A and option B involve 0. So let's put x equal to 0. You get what? Tan of fn of 0 will give you what? N by 1. Okay. 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 So now what do you do? Now this is just sum of squares of first and okay. So this is it. So what are the squares of first 5 natural numbers? 25 plus 16 plus 9 plus 3, 9 plus 4 plus 1, no, 5. This is what? 50, 55. This is correct. Option A is correct. Is it clear to everybody, or do you have some doubts? I'm just using telescopic series, expanding this. Okay, tan inverse of x plus n minus tan inverse of x equal to tan inverse of uh, n by 1 plus x into x plus n. Okay. Now take tan on both sides. We get tan of fn of x is n by 1 plus x into x plus n. Okay. Next, similarly, tan 1 plus f dash of 0. Okay. Okay, by 1 plus tan square of f of 0. So that means 1 plus n square by 1 plus f dash of 0. Is there any short way? But you can do that by differentiating this and stuff. You'll find out that this is not the right option. Okay. And limit extends for any fixed positive integer and limit extends to infinity tan fn of x. Okay. This is tan fn of x, no? This is not 1 by n. As x tends to infinity, this denominator also tends to infinity. So this thing will be n by infinity. This will go to 0. So the option is not 1 by n. This is also wrong. For any fixed positive integer n, limit x tends to infinity, secant square fn of x equal to 1. So 1 plus tan square fn of x. So 1 plus, so limit x tends to infinity, 1 plus tan square fn of x equal to what? You have to check if it is 1 or not. No, okay, this is 1 or not. So you can cancel 1. That means they're asking if limit x tends to infinity, tan square fn of x is equal to 0. But that is true because the limit x tends to infinity, tan of that thing is 0, because this thing goes to infinity, n by infinity is 0. So square of it also will go to infinity. So option D is also correct. Okay. Okay. That is the third problem. Now we are here for the fourth problem. Limit x tends to 0, a minus this thing. Okay. So generally, you can solve it using Hospital's rule also, but it's advisable that you take some steps with simplified. I mean, you should always use Hospital rule once you reduce it to the simple form. Now we rationalize this. What do you get? You get x square by a plus under root a square minus x square minus x square by 4 by x power 4. This x square will get cancelled. You get x square here. Okay. Now you see limit x tends to 0. This is finite. Is finite. That means when x you put x equal to 0 in this and this, you get finite number. Okay. Now if this is non-zero, if this is something, some non-zero number, some constant, you see, you put x equal to 0 here, you get 1 by this thing is infinity. So that means for numerator should be 0 when you put x equal to 0. So what does that mean? 1 by a plus under root a square minus 0 is a. 1 by 2a minus 1 by 4 equal to 0. So a will be equal to 2. Understood? Because you see, if numerator is something non-zero, some finite number, that finite number by infinity, because x tends to 0, 1 by x square is infinity, that will be infinity. But it is finite means for numerator must be 0. So a equal to 2. Now it is easy to compute the limit. Okay. So what is that? So you can just put, you get the answer as 1 by 2 plus under root 4 minus x square minus 1 by 4 by x square. This is as limit x tends to 0. Now you can use that we call that. If you put x equal to 2 sin theta, what do you get? 1 by 1 plus sin theta. Okay. So now we can simplify this. This is the standard formula because now there are no constants. It's a laborious calculation because you see, this if you're preparing for JEE, you are given this 1 plus x whole inverse and all these expansions. So just use this expansion and simplify that. So the x square will get cancelled there. So you get the answer to be L equal to 1 by 64. As we already discussed, I keep saying in every class, we will skip the lengthy calculation. This class is meant for teaching you techniques and techniques only. Next, let a comma b belongs to R such that x square sin bx by alpha x minus sin x equal to 1. Then what is the value of 6 times alpha plus beta? Okay. Now you see, this is what? Limit x tends to 0. X square sin beta x by alpha x minus sin x. Okay. Now how do you solve? This is also given to be equal to 1. Okay. So okay. Okay. Now we see we can simplify this. This is same as saying limit x tends to 0, x square. You see, whenever you see term, I replace it with the argument of the sign because you can divide and multiply the same thing always by alpha x minus x equal to 1. So what do you get? Limit x tends to 0 beta x cube by x into alpha minus 1 equal to 1. Cool. Now this is x square. Now you see, for this to even be defined, it should be of the form 0 by 0, right? Otherwise, you see, if the denominator is not 0, only the numerator is 0, the limit would be 0. So the denominator must be 0, and then you get 0 by 0 form, you can do something. But now you see, so now you see, if the denominator is not 0, say alpha is not equal to 1, what happens? Something by non-zero, it's a constant. So if when you plug x equal to 0, it goes in the numerator and you get the limit to be 0, but the limit is given to be 1. So that means what? Alpha should be equal to 1. Okay. So if alpha equal to 1, you plug in here, what do you get? Now again, the given function is of the form limit x tends to 0, x square sine beta x by x minus sine x. This is equal to 1. Find beta. Okay. So now, again, you please use the expansion of sine x as sine x equal to x minus x cube by 3 factorial plus x power 5 by 5 factorial, so on. So x minus sine x will give you what? So from this, x minus sine x equal to x cube by 3 factorial minus x power 5 by 5 factorial, so on. So write that here, take their inverse. Okay, take the inverse, like 1 plus x whole power minus 1 is 1 minus x plus x square. Do this thing and simplify the calculations and put the corresponding coefficients of x square and all to be 0. You get beta equal to 1 by 6. Do the calculations, that will be time consuming, right? But please do them at least after the class. Okay. So if beta equal to 1 by 6, alpha equal to 1, you get what? 6 into 1 plus 1 by 6, which is 6 into 7 by 6. This is equal to 7. So the answer is 7. Okay, that is the fifth one. Okay. Now let m comma n be two positive integers greater than 1. If limit alpha tends to 0, e power cos alpha power n minus e by alpha power n equal to minus e by 2, then the value of m by n is. Now you see, first what I'll do is I'll take e common. E into e power cos of alpha power n minus 1 by alpha power n. Okay. It is equal to minus e by 2 as limit alpha tends to 0. Okay. Now you see, this. If alpha tends to 0, alpha power n also tends to 0. Okay. Then cos of alpha power n tends to 1. So cos of alpha power n minus 1 also tends to 0. Call this variable p. Okay. That means what? You are doing first limit p tends to 0, e power p minus 1. Let's divide and multiply by p minus 1. Now we'll investigate p minus 1. Okay. So what is cos theta minus 1? That is 2 sine square. Okay. And this is what? This is limit a power x minus 1 by x. Okay. This is p. No, sorry, sir. So you know the standard formula, right? I hope you all know this. Limit x tends to 0, a power x minus 1 by x. This is a standard form. So bring it to that form and substitute that, you get what? You get e. Okay, a power x minus 1. And next, when you simplify this, okay, so we'll do it. Don't worry. This question is just limit p tends to 0, e power p minus 1 by p into, now again we'll write it in the normal form. Okay, limit alpha tends to 0, cos of alpha power n minus 1 by alpha power m. We'll simplify this because this one is in the standard form. This is cos theta minus 1 is 2 sine square alpha power n by 2 by alpha power n. Now you see this is limit alpha tends to 0. Now multiply and divide by alpha power 2n by 2 power by 2 square into alpha power 2n by 2 square. Why am I doing this? Because 1 by alpha power m into sine of alpha power n by 2 by alpha power n by 2, this entire thing whole square into alpha power 2n by 2. Huh. This is 1, no? Because alpha tends to 0 means what the entire thing will go. So you're left with what? Alpha power 2n minus m. Correct. So this is equal to E and this is equal by 2 into oh, this is minus, no? There is a minus here. And this is E here because when you substitute the limit, you get E. So equating this equal to minus E by 2, you get what? This will get cancelled, this minus will get cancelled, E will get cancelled. So alpha power 2n minus 1 equal to 1. So 2n equal to m. So m by n must be equal to 2. Clear? M by n is equal to 2. So this is one example where you should just get it into the standard form like this. Always try, whenever you have exponents, when the variable of the limit is in the power, try to get into this form. That will simplify your life a lot. Okay, I hope you understood. That's what we have done. We have simply written it in terms of two standard forms. One is e power x minus 1 by x. Second one being sin x by x, that also we know, e power x also we know, we just substituted. So at the very glance it doesn't look like it's a standard form of a limit, but once you simplify and make some adjustment, you can see that it is a standard form. Okay, next one is okay, we'll do it here only, I guess. Sine of under root. Okay, so you're given all the four, f2 f3 f4, no, we'll do f2 and f3. Based on that, we'll do option elimination. Sorry. Sine of x by tan inverse of x, where inverse trigonometric functions tan inverse assumes a value minus pi by 2 to pi by 2. X not equal to 0 means what? X could be negative and positive, correct? So that means what? If x is negative, sin x is negative. If x is positive, sin x is positive within this limit. Okay. Now f2 of x equal to minus sin x by tan inverse of x for x less than 0, and that is equal to sin x by tan inverse of x for x positive, correct? Is this even continuous? Because at x tends to 0, this will be minus 1, this will be plus 1. The limit doesn't exist at x equal to 0. So it is continuous everywhere but at x equal to 0. But x equal to 0 is valid here. When it lies, 0 belongs to belongs to 0. Obviously, it's not continuous. So f2 must, if it's not continuous, there is no way that it can be differentiable. So this will be 1. So q equal to 1 means what? Option B and option option A and option C are gone. Equal to 1. Now what shall we do? F3. We'll do F3 because then we can decide if it's option B or option D. So it should be either 2 or 4. We'll see which one is it. So step of sine of log of x plus 2. Denote this. See, first thing, it's a step function. So the values it can take is 0, minus 1 or plus 1. Clearly it is discontinuous. Okay. It is discontinuous means what? So R should be either be 2 or 4. Okay. So you see, when it is increasing, sine of log of x plus 2. The step, if it lies between -1 to 0 and strictly not equal to 1, it goes to -1. If it's -1, it's -1. If it's 0, it's 0. If it lies from 0 to some number less than 1, again be 0. If it's equal to 1, it will be 1. So what? Okay. So what is it with option C? X equal to 0. Just at x equal to 0, obviously it is continuous and differentiable. We are not asking about at all points. See, all options involve only at a single point. Correct. So yeah, this is 4. So obviously options B should be the answer. But anyway, if s equal to 3 is fixed, right? So we do not have to solve for s equal to 3. Just for sake of completion, we'll solve B. Okay. B is 4 or 2. B is 2 or 4. First of all, okay, that means we should check for the differentiability of that to divide it. Okay. So clearly it's continuous. Okay. If it's continuous, then which option is there? Oh, both of them are continuous. Huh? Cos of x square into 1 by 2 into under root e power minus into, what is the derivative of that? E power minus x square into 2x minus. This is its derivative, right? Okay. It's clearly continuous, but is it differentiable? That's what we'll have to check now. I think e power minus x square is not differentiable, right? E power minus x square should not be differentiable. If x square is differentiable, x square is differentiable. So what did we get? We got q equal to 1, r equal to 4, s equal to 3. Oh, since there is only one option with all this, right? 1, 4, 3. So obviously D is the answer. Why was I even doing that? Okay. So this is not the right way to do. I'm telling you this is wrong. But given the constraint in the JEE Advanced exam, the main target of yours should be to minimize time for solving the problem. So that's what I've done. Generally look for options in which there is distinction. So why did I solve Q first? Because there are only two options with Q. So if I get Q value as something, I can discard the other two options. So Q cannot be equal to 3 or 2. Q can only be 1. So option A and B or C are obviously eliminated. Now, if I choose equal to 2 or 4, then I can obviously check the question, because if I go to S, that it is useless, right? Because in the both the options the same option. Check for options which are different and which are easy. So then I've gone to R, which says R might be 2 or 4. Then I did R came out to be 4. It's differentiable at 4 and its derivative is continuous. So obviously option D is the answer. So that's how we should minimize time, but it is not ethically correct. This is wrong. If you want to increase your knowledge base, it is not the right way. But given the time pressure and the competition of JEE exam, you can do this. 0 square plus f dash of 0 square equal to 85, in which of the following statements are true? Okay. Now you see there is a interval. Okay. Now you see we only know about 0, so let's just investigate. If f dash of 0 is 0, f of 0 can be what? Square root of 85, which is beyond 4, beyond 2. So f dash of 0 is not 0. That means what? F dash of 0 is either positive or negative. We do not know. That means f is somewhat strictly increasing in some open interval around 0. No? That is by definition of differentiability. Very small, minus epsilon to plus epsilon. F is strictly increasing or decreasing. Okay. So obviously, if f dash of 0 only, then that means it's a slope straight line. If f dash of, if something is not 0, f dash is either positive or negative. That means it's either increasing or decreasing. So in that case, obviously f is 1 1, right? In that small interval, you do not know which numbers they are because that depends on the function and how much its derivative is varying and all that stuff. Okay. Next, there exists x naught belongs to minus 4 comma 0 such that f dash of x naught is less than 1. Okay. Given a comma b, interval open interval a comma b, you know by Rolle's theorem there exists a c such that f dash of c equal to f of b minus f of a by b minus c. Correct. So x naught belongs to minus 4 comma 0. Let's see. So there exists a c such that f dash of x naught equal to f of minus 4 minus f of 0 by minus 4 minus 0. Now you see, this is also same as f of 0 minus f of minus 4 by plus 4. Now we see f of 0 and f of 4 both lie between minus 2 and plus 2. So we are finished till up. Okay, we'll do this problem from the beginning. Okay, so if f dash of 0 is not equal to 0, that means what? F must be strictly increasing or strictly decreasing in some small interval around 0. That means obviously it should be increasing 1 1, right? In case of increasing or decreasing, the function is always 1 1. Then we have also done this f dash of x like f of minus 2 less than or equal to f of 0 less than or equal to 2. Minus 2 less than or equal to f of 4 less than or equal to 2. When you take the quotient, f of 0 minus f of 4 by minus 4, this always lies between minus 4 to 4, but this quotient is equal to f dash of x naught for some number between 0 to 4 less than f dash of x naught less than uh, okay, sorry, less than or equal to 1. No, this entire quotient, so when you divide this you get minus 1 to 1, right? So mod f dash of x is less than 1. So limit x tends to infinity f of x equal to 1. This need not be true. Why should this even be true? We can also give a counter example like take f of 0. No, so take sine root 85. Yeah, and this is f of x root 85x. This f of 0 will be 0. What is f dash of x? Root 85 cos 85x. When you add them both, you get what? 0 plus 85. But the limit of this doesn't even exist. So this is wrong. So next it's there exists an alpha belongs to minus 4 comma 4 such that f of alpha plus f double dash of alpha equal to 0. Okay. Let's define g of x equal to f of x square plus f dash of x square. Okay. This thing plus this thing square. Now what is g dash of x? 2 times f of x into f dash of x plus 2 times f dash of x into f double dash of x. This is equal to 2 times f dash of x into f of x plus f double dash of x. Just to get this expression, I have defined g of x like this. Just to get this expression because the answer involves that expression. There exists an alpha belongs to minus 4 comma 4 such that this is 0. That means you see, does there exist an alpha g dash of alpha equal to 0? Because f dash is not 0. Because if f dash is 0 at some point, f dash of f of x must be equal to square root of 85, which is not possible. Is this true? Now you see f of x is less than 4, f dash of x is less than 1. So g of x is less than or equal to, there exists a point such that it is less than or equal to 5. So we'll see there must be at least be one point, no, from minus 4 to 0, 0 to 4. So let P be the point in minus 4 to 0 such that g of x equal to 5. Q be the point here at which this is true. So obviously there exists at least two such points. Why? Because suppose if there is only one point, that means what? That at that point g of p value is 5, so it should be less than 5 always, but that is not true. At 0, what is its value? This value at g of 0 is what? G of 0 equal to 85. So obviously if there is only one point, that means what? The function should be strictly less than this everywhere. That is not possible because at g of 0 it's 85, so obviously it should increase. If it's increasing, it should again decrease. So g of x is less than or equal to 5 means what? G of p equal to g of q equal to 5. then there exists a point in between -4 to 4 such that g dash of r equal to 0. That r itself you take to be alpha. If that is 0 means what? F dash cannot be 0. So obviously the sum is 0. So option D is also correct. Next we come to the ninth problem. Ninth problem says f mass from 0 to pi to r twice differentiable. And see, whenever you get such functions, there's a trick which you should follow. It's very short and very nice. Limit t minus x going to 0. So f of x sine t, add and subtract f of t sine t. This is given to be sine square x. Take sine t common, you get what? Sine t into, then you get f of x minus f of t by t minus x, and t minus x goes to 0. So that is a derivative. Okay. So if t tends to x means what? This is continuous. So sine x f dash of x. Now you put this as okay. So this is f of t sine x minus f of t sine t. So this will be minus sine x derivative times f of x. This is equal to sine square x. Divide by sine square x on both sides. I'll tell you why you are doing it. So now if you divide, what do you get? Sine x into f dash of x minus f of x into sine x derivative by sine square x. This is equal to 1. But this is in the form of a quotient of a function. So that is derivative of f of x by sine x, sorry, minus f of x by sine x equal to 1. So now if you integrate, you get what? F of x equal to f of x by sine x equal to minus f of x by sine x equal to x plus. Just to determine the constants, they have given you a condition f of pi by 6 equal to minus pi by 12. So minus of minus is plus pi by 12 by 1 by 2. This is equal to minus pi by 6 plus c. Okay. Okay, sorry, pi by 6. So this is pi by 6 equal to pi by 6 plus c. So c equal to 0. Hence f of x equal to x sine x minus x sine x. This is the cornerstone of the problem. Once you derive this, everything else will be trivial. F of x equal to minus x sine x. Deriving this is what requires some thought process. But once you do that, verifying all those options is very easy. I mean, if you have cleared JEE, you would be able to do it. So if you check it, clearly option A is not correct because f of pi by 4 is minus pi by 4 root 2. So option B, option C, option D are the correct answers. So the reason I wanted to emphasize this is, remember this technique, adding and subtracting f of t sin t. I know that is very useful. Adding and subtracting some number, not just in calculus, even in trigonometry, complex numbers, adding and subtracting so to get into a desired form is a very useful technique. Okay. Now comes 10th one. Okay, continuity and differentiability is what they are asking. So firstly, x mod x. So that means it is x square for x greater than 0. It is minus x square for x less than 0. So obviously, how will the graph look like? Something like this. So what about this? It's continuous, it's differentiable, and it's also strictly increasing because you see from -1 to 1, it's increasing, right? So obviously A would be PQR. So this is the option. Let's do it for B. It involves mod, so it's not differentiable. It is continuous. It's it is also strictly increasing because mod x is strictly increasing. It also is strictly increasing. So option B is P comma R. Option C. Is it continuous? No, because step x is not continuous. So continuous plus a discontinuous function at a given point is discontinuous. So option B will not hold. It's not if continuity fails, its differentiability is no longer guaranteed. It's strictly increasing because x is increasing, step x is also increasing. It's strictly increasing. It is not differentiable. Not as one point, multiple point is not differentiable. C is r comma s. Clearly, B is continuous. It involves mods. It's not differentiable. It's strictly increasing. It's not differentiable. Okay. It is not strictly increasing as well, mind you. So it's P comma Q. So option C is the correct answer. PQR, PR, RS, PQ. Now you see, this is an easy problem because it's just sketching the graph and checking if it's differentiable. You just have to remember some basic points like modulus is never differentiable and stuff like that. Once you do that, everything else is trivial. Okay. So any doubts, please ask me. And I'm extremely sorry because of that power outage. Okay, I did not know what to do. I did not have power. So